Hello, good evening, my minions, my warriors. Welcome to the next session of Current Electricity. And today we are going to study about voltmeters, ammeters, and we are going to start with galvanometers today. So these devices, like the name suggests, they are used to measure voltage difference or to measure the current. But how exactly do they do that? What is the theory behind it? That's what we're going to do, and we are also going to solve a lot of problems. And these days I would also like to mention that these devices look very different. They are now being replaced by either analog multimeters or digital multimeters, and I'm pretty sure you would have seen some of these at some point of time, or hopefully you will see it very soon. So welcome aboard with me, Shreyas, your master teacher for physics at Vedantu going live. Hello everyone, how are my warriors? Hi Samuel, Ankit, Surya, PL, Priyanka, Nancy, Munna Bhai, hello Akashian, Mulhil, hello Emula, welcome aboard. Good evening, good evening, good evening. I'm Shreyas, your physics master teacher at Vedantu going live, and I teach on Enthuse and also the Vedantu platform. And I have been training and coaching kids for JEE and NEET and other such entrance examinations for the past 10 years. And during this course, I have produced amazing results, and a lot of my students are now in IITs, NITs and BITS and top-notch colleges. And many of them have now graduated and are probably in some really high-paying jobs. And not just that, many of my students have got 2-digit All India ranks, and I really like to boast about it. Thank you very much for joining in, and this is a very special channel. This is an English medium channel. I don't think many channels are out there which are teaching in English, and we are committed to give you quality content. We are committed to give you all the important and relevant information for all the engineering entrance examinations. And right now we are preparing for all the 2021, 2022 and 2023 aspirants. All three series running simultaneously. So before we go ahead, do not forget to smash that like button out there, because it means a lot. And if you want to know more about me, you can also follow me on my Instagram handle, that's Shreyas_Vedantu. And if you're new to this channel, hit the subscribe button out there. Hi Rahulji, hi Srivarshini, hello Pradyumna, hello Ragunesh, ABCD, Ishan, Swarna, welcome aboard. I don't think it's announced, ABCD, I'm not sure, but it's too early to be announced. Hello Danny. And guys, did you check out the vaccination video? How many of you checked the vaccination video? If you have not checked it out, go check it out. It's hardly 59 seconds. Yep. So you can go check it out in case you have not checked, and do let me know what you feel about that in the comment section of that video out there. Hi Rajneet, good evening. Hi Surya. Surya, I'm in Bangalore, north of Bangalore. Yeah. Okay. So this is a modified timetable. It's the updated timetable because yesterday I was not well so much, so I have just changed the timetable. So tomorrow there is going to be a class on addition of vectors, and a session with Vani ma'am on Saturday 7:30. So all about women in science, and we are going to have an amazing Menti quiz with lot of students on that day. So it's going to be Vani ma'am versus me in that Menti quiz, and Vani ma'am is going to come up with few questions for me. I'm going to come up with few questions for Vani ma'am. Let's see how it's going to be, and I have a lot of amazing questions for her too. So I'm pretty sure you guys are excited for it today. Yo, Ankit, how do you do biology? I mean, yes, Vani ma'am is going to come. You can even do biology from Biotonic. That's a special channel just for biology out there. Rahulji, I'm originally from Pune, but right now I'm situated in Bangalore. Yo, Pavitra, welcome aboard. Yes, Vimula is excited. Good to know that. Hi, Danny is also excited. Very good. Hi, Alini. Hi, Pankaja. Welcome aboard. Welcome aboard. Vanakkam, I just know. Tamil Terila. That's all I can say right now. Okay. All right. But I'll definitely learn for sure staying with you guys. Okay. Great to know that, Samuel. Yeah, I know Pavitra is excited too. Look at that. Munawai, I already have overcome that vaccine fever. That's why I was not well yesterday. Yeah, so I had some mild reactions, but now I'm perfectly fine. So that video, actually that vaccination was done almost 3 days back. So yeah, that's how it is. Oh, Vedantu's office, it's amazing, Ishan. By the way, I will have a special session with you guys just to talk and do a casual conversation. You can ask me all this stuff out there, and I'll also show you all the pictures and all that. I will ask you to ask me all the questions in advance so that I can come up with pictures, so that I can showcase all those answers which you are waiting for, and it will be beautiful to do that way. By the way, these are the Vedantu results for this year. The 12th standard students who have scored more than 90% from Vedantu, that's around 70%, that's 5 times higher than national average. From JEE Advanced, for JEE Advanced, Vedantu students, if you see the percentages, that's around 8.25% of students are qualifying for JEE Advanced. All right, and not just qualifying but also getting into IITs. That's what it is, and it is 6 to 7 times higher than the national average. And all this is happening just because of the teachers, the study material, the assignments, the methods by which we teach, the whole ecosystem built around teaching. It's not just teacher and student. There are many more things like counseling, class teacher, doubt expert, the content, the soft and the hard copies that you get, and also the guidance that you get, the special sessions that you get, the whole student teacher bonding. A lot of people feel that in online student and teachers cannot bond well, but in fact I feel that I am bonding much more than what I was bonding in offline. In fact, a lot of shy people out there are also coming out because they are not scared anymore. They want to ask their doubts, and I'm really happy about that. And you can see the results are out here. I mean, come on, 1 in 2 students of Vedantu have already qualified. So many students got 100% in JEE Mains, and that's a really huge number, guys. So all this you get in the pro subscription with the micro courses, the live teaching, the tests, the assignments, all of this. The link is there in the description box below. There are 3 packages: Light, Classic and Plus. You will know more about it towards the end of the class, but remember, you can always use this coupon code SHHPRO to get a lot of discount. So that's what you need to remember, and please check out the link later on. Alright, so let's get going to Galvanometer out there. Ankit wants IIT. Yes, sure, Ankit, definitely. Yeah, definitely, Ankit. I mean, you're here, and not just you, everybody is out here to get into IIT, and we are going to work really hard for you. And like you have seen, we have been staying committed for all your dreams, guys. Is it creating any serious things? Not at all, Vikram. So guys, that's what I told. Some people might get mild reactions, but that's okay. In fact, even when you get the polio vaccine, when you were kids, you would have got fever, just that you won't remember it. So guys, people are unnecessarily creating rumors. People are unnecessarily, spreading fake news, that it is made of that, it is made of this, it will do that, it will make you do this. Guys, that's all wrong. Please do not believe such things. And if you find such forwards in WhatsApp or any other groups, please educate those people. In fact, I have been very clear about this in my WhatsApp group, be it any group. I quickly respond to such messages, and I'm like, hey, you guys are wrong. You know what? This is the actual fact. So please, you guys are educated people. You guys are smart people. You guys are preparing for JEE. So I'm pretty sure you should be the front runners. You are the young warriors who should stop all these fake news. Please do that, especially the older generation or the uneducated people are doing this. So do not let them do that. Yeah, very good, very good. Okay, I put my vaccination 3 days back almost. Yep. Yeah. Oh yeah, Vikram, I missed you too because I had some mild reaction. That's why I couldn't, come yesterday. Okay. Niharika, it will take some time for the droppers batch to start. It will take 1 month. Okay. Yep. Okay. Great. Oh, definitely, Rahulji. Why do you think we started this channel? This channel is started only for all the people, not just South guys. Rahulji, it's nothing about South and North. It's about all the Indians who are studying in English medium. If you are in English medium, you should study in English. It's not a good thing if you are studying in English medium and then you are studying in Hindi. Then what's the point of studying in English medium, right? I mean, come on, think about it. Oh, okay, I will let you know which vaccine I took if you post a comment on that video, not in this, not right now, not in live session. I will post it in the comments if you ask me a question in the comment section of that video. Okay, so let's talk about galvanometer, guys. I know you guys just want to talk to me so much. Okay, this clearly tells me I should have a session with you guys where I just sit and talk to you guys. Don't worry, I'll come up with that soon. Okay, now this is how a galvanometer first of all looks like. You can see there is a scale, there is a needle, there is 0 over here, there is some plus side and there is some minus side. Sometimes there might not be a minus side, but that's okay. Okay, so the thing about a galvanometer is that whenever a current passes through the galvanometer, so the current passes through the galvanometer, according to the current, the needle deflects. More current, more deflection. Less current, less deflection. No current, no deflection. Reverse the direction of current, reverses the deflection. I'll repeat. More current, more deflection. Less current, less deflection. No current, no deflection at all, like this. And if you reverse the direction of current, then the deflection will go on to the other side. So the whole idea of the galvanometer is that the deflection, okay, the deflection, which is theta, all right, is directly proportional to the current through the galvanometer. So it's directly proportional to that. Yeah, as simple as that. And what does it, what's the basic functionality, or how does it function? The thing is, there is a coil, and that coil, when the current flows through that coil, there is a magnet, and due to the magnetic effects, the coil gets deflected. There is a spring-like action which pulls back the needle when the current goes off. So that's based on magnetism principles, which you will study in detail when I talk about the same instrument in magnetism, and I will explain it to you in detail with the help of torque and the Lorentz forces, the magnetic moment, and all such stuff. So don't worry about it for now. Just remember that the deflection is directly proportional to the current passing through the galvanometer. Okay, now the most important things, okay, I'm just giving you all the theory pointers so that all of this is there in the notes. By the way, in case you have forgotten, remember all the notes will be there in our Telegram group down there. So join our Telegram group so that you can get all the notes, the entire PDF as it is out there. So do not forget that. All right. So Akarshan, can you just do one thing? Can you just replay back the session a little bit? Even in a live session, you can go back and come to where you are, where I am right now at 2x speed. That's the advantage when you study on YouTube too. Okay. So it's an instrument which is used to measure current of small magnitude, generally milliamperes or microamperes. Remember, you generally use galvanometer in series with the branch in which you wish to measure the current. Now it is obviously going to make sense. You connect it in series. For example, okay, there is a complex circuit like this. Okay, there is a complex circuit like this, and you want to measure the current in this branch. You want to measure how much current is flowing in this particular branch. What will you do? You will put the galvanometer over here. You are going to put this device over here, and only then it can measure how much current is flowing through that particular branch. So that's why it is said that it is connected in series with the branch in which we wish to measure the current. That's what it says. Great. And the symbol for that is the standard G, okay, with a circle around it, and the two terminals are shown on the sides. Yeah, that's how it is. Oh, all the best, Rishi, and all the other people who have their VIT EEE examinations. Thank you, Umraj, so much. Yes, Kumra, I have taken rest yesterday. That's why I did not conduct my classes yesterday, like you guys know. So I took my vaccination almost 2-3 days back. Yep. Okay. I hope that's clear. I hope Akanshan is also going to come back very soon after catching up. Okay. So having said this, another important thing about galvanometer is that there is a limit till which it can deflect and the current can flow. See guys, when the deflection happens, okay, more current, more deflection, but there is a point till which it can deflect. After that, if more current flows, either the needle will break or the coil itself will burn off because of excessive current. So each coil has some resistance and it might get burnt if the current exceeds that current value, or that needle itself might break if it goes beyond that particular point. So this is called as the maximum current which can flow through the galvanometer, and that current is also called as full scale deflection current. So full scale, as in like the needle has gone till the extreme point, That's why it's called as a full scale deflection current of the galvanometer. So the full scale deflection current also, it indicates that the current of that instrument, how much it can tolerate. So that's the maximum permissible limit. It cannot tolerate more than that current. I hope that's clear. Everybody clear about this? So less current means what will happen? If less current will go, then what will happen? The deflection will be less. More current, more deflection. It's directly proportional. So remember that. The current is directly proportional to the deflection. That's what happens. Everybody clear till this point? Shall we solve a problem on galvanometer? If you guys are ready, then go hit the like button so that I can see those likes increasing. Number one. Number two, say yo in the chat box. Come on, do that. Okay, Minecraft, don't worry, I'll take your name again and again if you keep answering the questions correctly. Oh, Vikram, I can read many chats in this chat box. I mean, I have a big screen in front of me in which I can read all the chats. So, yep, that's how it is. Okay, chalo, let's go ahead. Somebody said yo Anna. Who was it? Akanshan. Okay. All right. So here's the first question coming up on your screen. The figure shows a scale in microampere and the maximum deflection. So the maximum angle by which the needle can deflect is 45 degrees. I hope you can read that scale. Okay. So by the way, this number over here, if you cannot read it, this is 500. And this number over here, if you cannot read it, this is also 500. And this number, if you cannot read it, this is 0. Maybe some of you are watching on the mobile phones. Probably you might not be able to see it. So that's why I'm writing it down here. What is the full scale deflection current and the sensitivity? Come on guys, let me know the answer in the chat box. Oh yeah, Omraj. Great. High five, Omraj. Let's see. How many of you guys can type out both the answers in the comment section below? What is the full scale deflection current and what is the sensitivity? Okay, come on guys. Come on all my minions, my warriors. ABCD, I think that is wrong. Be careful guys, be careful. Think again. Surya, no, it's wrong. Samir, it's wrong, I guess. Come on. What's the full scale deflection current? What's the maximum reading it can measure? See, this is 0, this is 500 plus, this is 500 but minus, this is negative side, this is the positive side. What's the maximum current it can measure? So the I max, the full scale deflection current. Alright, so the full scale deflection current is 500, but remember this is a scale in microamperes, so this is microamperes, as simple as that. So that's the maximum current which should flow in this galvanometer. Beyond that, it might burn or it might damage that instrument. Great. Next, the sensitivity. The sensitivity of that instrument means how many amperes does it show per degree. So if it deflects by degree, you can see the units out here. In fact, that should be the hint for solving the problem. So per degree, how many amperes of current does it measure? That's the meaning of sensitivity in this case. So you can see for 500 microamperes, it deflects by how many degrees? It deflects by 45 degrees. Isn't that correct guys? It deflects by 45 degrees. So just divide by 5, numerator and denominator. That's going to be 100 by 9 microampere per degree. That's your final answers. Yes, that's your answer. Correcto. I hope this is clear. Praveen, I hope you understood this now. Okay, as simple as this. This is the maximum deflection current, and sensitivity means how many microamperes or amperes or whatever per unit deflection. So in this case, the units were degrees and on the top it was microamperes. Okay, so that's the answer guys for this particular question. Great. Now let's get going to the next device, and that's ammeter. Now one thing I would like to tell you is that ammeter and voltmeters are actually nothing but galvanometers, but with a special modification. Now what exactly is that modification? That's what I want you guys to understand. So what did I just say? ammeters and voltmeters are nothing but galvanometers with a small modification, and the theory behind it is what we are going to see. Okay, does theta affect current? No, wrong. Current affects theta. That's a wrong way of putting it. Okay, Minecraft, don't spam out here. Okay, so Minecraft, if you are in 11th, this series is not for you, bacha. You have the nurture series. This is for the 12th standard students, so please understand that. Sarthak, I have already taken a session on VIT EEE. Please check out the past videos. We did a mock test just day before yesterday, and I also did another session on last Sunday. So please go check it out. Okay. Now, ammeter. What's an ammeter? Ammeter is nothing but an instrument, obviously, to measure a larger value of current. So you might be like, sir, if I have a galvanometer, I don't need an ammeter, because what a galvanometer does is it already measures the current. But remember, galvanometer can only measure small values of current, not huge values. So an ammeter measures currents of large magnitude, and what it is nothing but a galvanometer, but with some modification, so that the range is enhanced, so that its capacity is enhanced, and the symbol for that is this one. Now that's pretty much standard. You would have seen this in your 9th or 10th grade. Now what exactly you need to do? Okay, now guys, I'll put forward a puzzle, a riddle, a very easy lallu one in front of you. Let's see if you can apply your brains. I will tell you that there is a highway. Okay, there is a highway. Okay, there is a road, and in that road only there is a section, there is a bridge, there is a narrow bridge, and only few vehicles can pass through it per hour. Only very few number of vehicles, because it's a narrow road, few vehicles can pass through it. If more vehicles will pass, then the bridge will collapse. So what you do is, because there are a lot of vehicles coming in, and there are only few vehicles which can go from A to B, what will you exactly do, guys, to solve the problem? Think about it. Which is better, ammeter or voltmeter, Ankit? Both have different purposes. So there is nothing like which is better. Both have, ammeter is used for measuring current, voltmeter is for voltage. So yeah, that's how it is. Come on guys, think about it. If there is a highway, lot of vehicles are coming in, but from A to B, very few vehicles can go, because it's a bridge, it's a narrow path, and you cannot allow too many vehicles. What will you do? Yes, correct, Aishwarya. Yeah, correct. Replace with a larger bridge, says Dragonesh. No, I'm not allowed to replace the bridge. Yeah, you connect another road. You have a bypass road, so that many vehicles can go through the bypass, and very few vehicles will take the bridge route. Okay, there will be some people who will go via the bridge route because it's shorter maybe, but there will be a lot of vehicles which will be taking the longer route, but it will be broader, maybe it will have less resistance. That's what happens over here in ammeter. Now, if there is large current coming in, you do not want that large current to go through the galvanometer. So you create a bypass with a lesser resistance. This resistance is generally much less than the galvanometer resistance. So what will happen? Most of the current will flow from here. Very few or small amount of current will flow through the galvanometer till whatever it can sustain. So you need to choose this resistance such that in parallel, such that when a large current comes in here, the current gets distributed in such a manner that this galvanometer can sustain that current. Yeah, so the current comes in here, large current gets distributed, most of the current goes here, small current goes here, but this small current should be bearable by the galvanometer, else it will spoil, it will get burnt. And you can see that that's how galvanometer, this behaves like an ammeter. So think about it this way, guys. Think about it this way. I have 100 amperes of current, huge current, but I give 99 amperes from here and only 1 ampere from here. I choose this resistance in such a way that this is 99 amperes, this is 1 ampere. So what will happen is that small current is flowing through the galvanometer. This galvanometer will deflect, and once it deflects, I can indirectly measure the current. I hope you get this point. So What this galvanometer is doing is it is only drawing a small amount of current of that larger current, and by that small current it is estimating, oh, that should be the actual current which is coming in. I hope you get the idea. I'll repeat, the galvanometer actually measures a small value of current, or it draws a small value of current. From that it can estimate how much current is actually coming in to the bigger one. I hope everybody is clear about this particular point. Yep, very good. And this is what an ammeter is. So you just put a resistance in parallel, that's it, that's called as an ammeter. So it's nothing new, it's just a resistor in parallel. Now what is this resistance in parallel called? This resistance in parallel is called as the shunt resistance. Usually this shunt resistance is much smaller than the resistance of the galvanometer. It's much smaller than the resistance of the galvanometer. Now because of that, what should happen? Understand the current which flows through the galvanometer, and if you compare the current which flows through the shunt, which current should be more? Which current should be more? Think about it. Which current should be more? Obviously the shunt current should be more. This galvanometer current will be much smaller than the current which flows through the shunt resistance. Keep this in mind. Yes, it should be, this galvanometer current will be much smaller than the shunt current. Yeah, if you compare that, because this resistance is very small, it takes away most of the current. So the current which enters inside over here, this total current is the galvanometer current plus the shunt current. So it's the sum of both. This is by Kirchhoff's current law. The current gets divided. So the total current I is galvanometer current plus the shunt current. Great. Now few things that you need to keep in mind out here, which are already taught to you in series parallel circuits. Remember, this and this are in parallel and in parallel circuits. In parallel circuits, we have already seen that the current across a resistance is inversely proportional to the resistance. We have already seen this fact. That means the current through the galvanometer upon the current through the shunt, okay, this will be inversely related to the respective resistances. So this will be RG will be here, and the R of the shunt would be over here. Keep this in mind. Yeah, so they are inversely related. I hope this is clear. Yep. Oh, why do we use shunt if not needed? The reason, Ankit, why we use shunt is because, let's say the galvanometer, let's say for that galvanometer, the max current which can flow is 1 milliampere. That's it, 1 milliampere can flow. But you want to measure till few amperes of current. What can you do? Obviously you cannot use that galvanometer, because if that few amperes of current will flow through it, it will get burnt. So what you do? You put a resistance in parallel, which I call it as the shunt. So most of that current will flow through here. Hardly any current will flow through the galvanometer, and that's it. I can measure it. Yes, that's it. Okay. Ria, you can post up all your comments after the video, and I'm not the chemistry teacher, Wasim sir is. Maybe you should ask Wasim sir which chemistry book to follow. Okay, great. So, when this much part of the theory is clear, I'm pretty sure you can start solving problems. Okay, let's start solving problems. And remember guys, the theory for the problems which I'll be using is provided in these next slides. Okay, so that instead of me writing it and then it does not come in the notes, I have made sure that it's in the printed form, whatever I am going to explain for the problems. So don't worry, all of this will be available for you in the session PDF or in the Telegram group when the PDF will be posted. Okay, so let's try doing this problem. Okay, this is supposed to be a moving coil. Okay, not a coving coil. A moving coil galvanometer has a resistance of 900 ohm. Let's try to analyze the problem. It has a resistance of 900 ohm. In order to send only 10% of the main current through the galvanometer, what is the resistance required in shunt? Let's try and analyze it. See, only via problem solving you'll understand how to solve problems of ammeter and galvanometer. Let's go step by step. there is a galvanometer which has a resistance of 900 ohm. Okay, so we have this galvanometer, and what's the resistance? That's given to be 900 ohm. Okay. Now, in order to send only 10% of the main current, you connect a shunt resistance. Shunt means a resistance in parallel. So I connect a resistance in parallel like this. So if the main current is I and only 10% of that current is going through the galvanometer, means how much current is going? I by 10, right? I by 10 current is going, and the remaining current, which is 9I by 10, is going through the shunt resistance. Yes, it's going through the shunt resistance. Is everybody clear till this point? Niharika, I will just tell you. Venkata, hold on, bacha. I will take some time. I might not respond in 1 or 2 days. It might take 5 days, 6 days, sometimes a week. So please do not expect me to respond within 1 or 2 days. It takes time because I have to respond to many queries everywhere. Understand that? Okay. So the thing is, I'll repeat, there was a galvanometer of resistance 900 ohm and you have connected a shunt. What is the meaning of shunt? Shunt means parallel. That's what you should keep in mind. You have connected a resistance in parallel such that out of that main current only 10% means total current by 10, okay, and the remaining 90% will go through the shunt. That's what is happening. So guys, what are you going to do now? What are you going to do now? Think about it. Think about it. Just use current is inversely proportional to resistance. So the law that I am going to use is that current is inversely proportional to resistance. That's all I need to do. So what is the current flowing through the galvanometer? That's I by 10. What's the current flowing through the shunt? That's 9I by 10. Okay, this was from the galvanometer, right? So this would be the galvanometer resistance. How much it is? 900 ohms. And this would be the shunt resistance. So guys, can you see from here what exactly is cancelling? 10 gone, I gone. So what will be the shunt resistance? It will be 900 by 9, which is 100 ohms, which is option B. Which is option B. Yes, correct. I hope this is clear. Everybody clear about this? Everybody clear about this? Shiva, that's a 11th standard series. I'll be taking class on vectors tomorrow. Yep. Okay. Yeah, please do not spam out here, guys. Great. So, did you see what is the job of the shunt? Did you see how shunt resistance is calculated? So, if somebody tells you, you know, the galvanometer can withstand, somebody tells you, the galvanometer can withstand a max current of 1 ampere, maximum current of 1 ampere. Okay, just think about it. And you want to convert it into an ammeter of 10 amperes. I'll repeat. Listen to me carefully. It's not the end of the problem. We have to think about it. Let's try and analyze this. The galvanometer can maximum withstand 1 ampere current. I want to convert it into an ammeter which can measure till 10 amperes. That means, can you see, only 10% is actually flowing through the galvanometer. The remaining 90%, where is the remaining 90% flowing? It is flowing through the shunt. Isn't this scenario same as this scenario? Isn't this scenario same as this scenario given in the problem? Everybody clear about this? Isn't it clear? Isn't it clear? So that means, what will you do? If the galvanometer resistance is 900 ohms, example, then you will connect a resistance of 100 ohms in parallel, that's called as the shunt, so that when 10 amperes come, only 1 ampere will flow and the galvanometer will deflect and you can measure that. The remaining 9 amperes will go from here and that's okay, you have bypassed it. Yep. I hope this concept is clear. That's why I do this problem, because not many people understand what's the working principle of an ammeter. So that's how it works. And let's go ahead with the next problem. Great, great, great. Let's see how many of you can get this conceptual question. This is two identical galvanometers are taken. One has to be converted into an ammeter and other one has to be converted into a milliammeter. Ammeter, milliammeter. Check the units. The shunt for milliammeter compared to the ammeter is more or less equal 0. What do you guys say? अख्तर खान, मुझे हिंदी अच्छे से आती है बट ये इंग्लिश चैनल है बच्चा, तो अपन है ना यहाँ पर इंग्लिश में बात करेंगे. ओके, चलो लेट्स सी. शिवा, please don't spam. I have already mentioned that. Om Prakash, see, that's not possible. If you are studying in English medium, you have to learn in English. Remember, when you grow up, it will be very weird if you use Hindi with English or if you use English when you are talking Hindi. Come on, if you check any of the news anchors or any of, all the famous personalities, they are talking in one particular language. So you should not have that habit of mixing two languages. It's not considered to be a good communication skill. Okay? Come on, let's see how many of you can do this. Shunt of milliammeter will be more or ammeter will be more. Yes. Shiva, don't have to worry. I'm not going to listen. I mean, come on, I'm obviously going to teach in English. That's the name of the channel. Okay, so don't have to tell me about that. Okay, chalo, let's see this. Okay, now when you have a galvanometer and a shunt, this is your galvanometer, this is your shunt, okay, and this is your main current, this is your main current which comes in and it gets distributed, of course, in both these parts. So think about it. If the shunt resistance is less, think about it, more current can be bypassed. More current can be bypassed. Now, if more current can be bypassed, that means the main current can be more. I hope you understand that. If the shunt resistance is less, then more current can be bypassed. That means you can have more main current which is entering inside. That means it is able to measure more amount of current. So think about it. The one is an ammeter, one is a milliammeter. So think about it. Which resistance will be more? The one whose range is more will have a lesser shunt. The one whose range is more will have a lesser shunt. So whose range is more? Ammeter. So the resistance of shunt, all right, for an ammeter is less than the resistance of the shunt of milliammeter. So hence, what should be the answer? It should be more. The final answer will be more. The resistance of the shunt of the milliammeter is more than the resistance of the shunt of the ammeter. You can see that it's more. Yeah, that's the answer, guys. Beautiful. Beautiful. Excellent. Thank you, Saurav, so much. Thank you so much. Let's see how many of you can solve this question. Rohan, I am not the director, dean or examination in charge of SRM. I don't know. Guys, I'll tell you one thing. This VIT, EEE, this SRM JEE, these examinations are not at all standard examinations. First of all, I don't know. A lot of questions come out of the syllabus. So many questions came from the mock test. I mean, there is no way of predicting. Plus, they don't release their official data. They don't release their, the branch cutoffs, their every year-wise cutoffs and all that. So there is no way of predicting when they are going to do what. So please do not ask me. I do not know that. For JEE and Advanced, things are pretty much clear, and whenever things happen, there are official announcements made. The syllabus is very well defined, and there is a proper structure out there. Okay, come on, let's see how many of you can do this. Raj, this is a 12th standard. Please read I hope you can see the comment section. I hope you can see the description box below. You can read it out there. Okay, let's see how many of you can do this. There is a galvanometer which has a resistance of 100 ohms and there is a full scale deflection current of 50 microamperes. What will you do to construct an ammeter of range 10 amperes and what will be the value of the shunt resistance? Come on, think about it. Let's see how many of you can do this. Come on my warriors. What do you think the answer is going to be? Just draw a simple diagram. You have a galvanometer. What's the resistance? 100 ohms. Okay, so let's draw a galvanometer of 100 ohm resistance. This is your galvanometer. Okay. Now you have to connect a shunt resistance. Okay. Well, I have drawn a shunt resistance. I want to find the value of the shunt resistance, and you want to construct an ammeter of range 10 amperes. That means the current which enters inside is 10 amperes. Okay, interesting. Now it is clearly mentioned in the question that the full scale deflection current, the maximum current which can flow through the galvanometer is 50 microamperes. Just 50 microamperes. That's very small. So guys, can you think and tell me how much current will flow from here? If out of 10 amperes, 50 microamperes goes here, how much current will go from here? Use Kirchhoff's current law. Use Kirchhoff's current law. It will be 10 minus 50 micro. Now 50 micro, which is 10 to the power minus 6, is negligible in front of this number 10. So can I not say this is almost like 10 amperes? This is almost like 10 amperes, guys, because this is micro, guys. So that's very small in front of the number 10. So it's almost like 10. Now the only thing that I need is current is inversely proportional to resistance. Remember, that's the only law we need, nothing else. Nothing else you need. So what do you need to do? Okay, the current through the galvanometer is 50 micro. Okay, micro means 10 to the power minus 6 upon the current through the shunt. Well, that's 10 is equal to, remember, inversely related. So this is the galvanometer current. So the resistance of the galvanometer will come down. This is the shunt current. So the shunt resistance, which I don't know, is going to come up. So what is RS going to be? Take this 100 over there. 50 into 10 to the power minus 6 into 100 divided by this 10 out here. 0, 0 gone. So this is going to be 5. That 0 goes 10 square, 10 to the power minus 6. So that's going to be 5 into 10 to the power minus 4 ohms. You need that small resistance so that all the current bypasses, because you can only allow very small microampere current over here. All the remaining current should flow here. So this resistance must be very small. You can see that out here. Is that clear? Everybody getting confidence in solving these questions now? Everybody understanding the concept of ammeter, everybody understanding the concept of shunt, everybody understanding how a galvanometer is being converted into an ammeter to measure a lot of current. Great. If you guys are getting it, please let me know in the chat box. Then we'll go to the next question coming up on your screen. I want you to be very clear about it. Guys, let me tell you one thing. If I want, I can complete current electricity within 4 lectures. Yes, if I want to. But I'm not doing that. Why? Because this is Pathfinder series. And Pathfinder series is a long-term series. That means I want to teach everything properly. If I wanted, I could have covered all the instruments in one go, but I don't want to do that. I want to take a lot of examples. So in fact, I have dedicated one more lecture for potentiometer only, just the problems of potentiometer. That would be the last class. And one special announcement for all of you. One special announcement for all of you. Guys, I am thinking I will conduct after every chapter a lecture on advanced problems. What say, guys? Advanced problems only instead of the Menti quizzes. What say? Let me know in the comment section after the video ends. Okay, let's solve this question for now. There is a battery of EMF 100 volts and the internal resistance is 5 ohms. Okay, the internal resistance is 5 ohms. It is connected to a load. This is the load of 95 ohms. Now there is an ammeter. That means it's made of a galvanometer. The effective resistance is 2 ohms. Okay, you don't have to worry about it. Just think this is having a resistance of 2 ohms. Think of it like a resistor. What would be the reading measured by it, and what is the percentage error in that particular reading? Let's figure this out. Okay, let's figure this out, guys. What will be the answer? Yo, let's do this. Let's do this. First of all, what would be the reading measured by it? Let's do this. Isn't this circuit just like, you have a resistance here, resistance here, resistance here. This resistance is given to be how much? 5 ohms is given. Internal resistance is 5 ohm. Load resistance, where is it? Load resistance is 95 ohms. Ammeter resistance is 2 ohms. That's what is given. So the current will be voltage. What is the voltage? 100 volts. It's 100 volts. So it is 100 divided by total resistance, which is 95 plus 5 plus 2, which is 100 divided by 102, which is nothing but 50 divided by 51 amperes. That's what it is. This is the current. It comes out approximately 0.98, 0.98 amperes approximately. Great. Thank you, Ankit, so much. Hello, Kavita, Teju, welcome. All the new students, please, it's a good practice. Say hello to all the others, and do not forget to hit the subscribe button so that you do not miss our future lectures. And we are a lovely family of warriors who help each other out, and please help each other out, guys, in case somebody is facing difficulty, and please don't let anybody else spam. Now, this is the reading measured. Okay, this job is done. This job is done. Now, this question is weird. It says, what is the percentage error in the reading? Now, guys, I have a question for you. Don't you think this ammeter has actually changed the actual current in the circuit? Because think about it. Without the ammeter, there would be some current flowing in it. Now, because you wanted to measure the current, you placed an ammeter and you measured it to be 0.98 amperes. But actually, that ammeter has changed the resistance of the circuit. That means, actually speaking, you are not measuring the true current. You are measuring the modified current because the ammeter's own resistance has changed the equivalent resistance of the circuit. Don't you guys agree with this? Don't you guys agree with this? Kavita, of course you can get 60 plus, even you can get 80 plus if you work hard, and if you can work every day at least for 8 to 10 hours. Definitely you can do that. I'm very good, Praveen. Yes, you can see that. Now, if that ammeter was not there, this is how the circuit would look like. This internal resistance, that's about it. This would be 100 volts, this would be 5 ohms, this would be 95 ohms, and this current then would be 100 divided by 95 plus 5, which is 1 ampere. This would be the actual current, but this current over here is the measured current. Guys, there is a difference, small difference of 0.02 amperes. So the percentage error is delta I upon the I actual current into 100. This is the error, this is the change upon original into 100. That's why percentage error. And that's going to be, come on, you can guess it from here. What is the change? 0.02. Okay, so 0.02. I mean, I don't have to do this, but still, into 100, that's going to be approximately 2%, because even this answer was an approximate answer. Anyways, this is almost 2%. No, Ganesh, it's not 1%, it's 2%. You can see that. The actual current was 1 ampere. It decreased, it changed by 0.02 ampere. So that's a 2% decrease. Yes, 2% error is there. Now, I put forward a question to you. This clearly tells me, if I want less error in my reading, my ammeter should have, come on, answer in the chat box. If I want less error in the reading, my ammeter should be such that, type your answers in the chat box. What do you guys say? Type your answers in the chat box. Come on. Think about it quickly. I'm waiting for all your answers, guys. Come on. Exactly, Chinmay. Exactly PL, exactly, very good. They should have very less resistance so that the resistance equivalent of that circuit doesn't change much and the current is hardly hampered. The best ammeter in this world will have zero resistance. That would be an ideal ammeter. Keep that in mind. Okay, so that's the answer. These are the exact numbers, but yeah, we got almost close to that. Remember guys, the classes in our Vedantu paid platform look something like this. They are much better than what you see on YouTube with all the slides and the chat box, which is much more regulated, with a second teacher out there to just answer your queries. Right now I am the only one who is conducting this class, but your actual class is divided into small groups, and each small group gets a class teacher whom you can type and get all your queries answered. And there are quizzes after every class, after every concept, and this is how a quiz looks like. And you can answer, participate in the quizzes. There are polls which are conducted. I can see who and all are giving which kind of answers, and at the end of it you will also get a leaderboard and you can see the entire analysis of how your performance was at the end of the class and even after the class, so that you can keep a track of your performance. Because in normal coaching you just feel that okay, I'm doing well, or you might just be sitting over there, others might be answering, but these classes are highly interactive. So those of you who think that offline is more interactive, let me tell you, it's not right. In fact, online is more interactive because you actually have these data points which can be measured, which keep a track of it. You can in fact see the entire history of how your performances in the classes have been. And this is in fact very motivating to push yourself to get up into the leaderboard. And let's talk about voltmeter. Let's talk about voltmeter. Yes, let's talk about it. Now, like the name suggests, it's used for measuring the voltage. Now this is connected in parallel. Please keep this in mind. It's not connected in series, it's connected in parallel, and the symbol is this one, the big V with a circle and those two dots with those lines. That's it. That's the symbol for the voltmeter. And it makes sense why it's connected in parallel. I mean, come on. Let's say I have a bulb. Okay, I have a bulb and I want to see what's the voltage difference across the bulb. See what is the word used? Voltage difference across the bulb. That means between this point and this point. I want to measure the voltage. So what will I do? I will connect a voltmeter across these 2 points. So I can measure the voltage difference between these 2 points. So that's why I'm saying it's connected in parallel to the device across which you want to measure the voltage. Okay. Now let's talk about how exactly a voltmeter works. At the end of the day, a voltmeter is nothing but an ammeter. Keep that in mind. It's a galvanometer, nothing else. So voltmeter is nothing but a galvanometer, but slightly modified. Now again, I'll put forward a riddle in front of you. There is a device. Okay, there is a device. I want to measure the voltage across this device, and I connect a galvanometer. Now think about it. What will happen, guys? Usually a galvanometer has very less resistance or very large resistance. Think and answer in the chat box. So this is my device, which is a part of a big circuit. So I connect a galvanometer in parallel to this device. So there might be some current coming in. Usually the resistance of a galvanometer as compared to other devices is very less or very large. Yes, it's very less. Correcto. Beautiful. No, Aishwarya, it has very less resistance because a galvanometer is just made of copper windings. There is a copper wire inside, and copper is very conductive. So the resistance of that big winding, big coil is not so much. It's few ohms. Usually the other devices have some mega ohms, kilo ohms and stuff like that. So it's very less. So what will happen? Most of the current will flow through this part. All the current will try to flow from here, and this device will have very low current. Guys, imagine you are trying to measure the voltage across this device. You connect a voltmeter or you connect a galvanometer, and the moment you connect it, that device hardly draws any current, and the device only dies off because it is not drawing any current or drawing very low current. It's like you're trying to measure the voltage across your AC or your fan, and you connect the galvanometer and that fan stops working or the AC stops working just because you connected that galvanometer. That would be really funny and ridiculous. You wouldn't want to do that. So what will you do? What will you do? You do not want the current to flow through the galvanometer. Not so much, but very little current should flow. Out of 100, maybe 1 or maybe 0.1% should flow, just so much that it can deflect the galvanometer and it can measure it. Just a sample piece. So small current out of the large current should flow through the galvanometer so that it can measure it, and the remaining current should flow as it is without affecting the device so much. That means what you need to do, you need to connect another resistance in series with a galvanometer. You need to connect another resistance, very large one, with the galvanometer so that the effective resistance increases by a large amount. Keep this in mind. Yes, the effective resistance will increase by a large amount. Now, when this happens, you will see the current, if the total current was I, this current will approximately be I. Hardly any current will flow through the galvanometer. This I will be much larger than Ig, and the reason for that is because resistance of galvanometer plus resistance of the one in series, alright, is much larger than the resistance of that device. This is very large resistance, so that's why hardly any current is flowing. Ig is very small and most of the current is flowing over here. I hope this is clear. Everybody understood this? Yeah, this is not called shunt. The symbol is S, but it is not shunt, it's called series. Shunt is parallel, not series. Shunt means in parallel. Series means obviously one after the other. That's series. Okay, so a galvanometer with a series resistance connected in parallel is nothing but a voltmeter. That's it. A voltmeter is nothing but a galvanometer in series with another big resistance. That's it. So you would be getting fooled to pay that extra bucks for a voltmeter, because at the end of the day, it's nothing but a galvanometer. Understand that? Clear? Beautiful. Amazing. Amazing. Yeah. Now, all the theory which you require, which I'm going to also use for solving problems, is going to be there in the session PDF. So you can join our Telegram channel. The entire PDF will be provided to you. But now let's start solving problems so that you get to know how exactly to use this theory. Now you're going to learn all the theory through problems, because that's the best way I feel, just like you learned ammeter to study voltmeter. Look at this question. And by the way, let me tell you, treat voltmeter or galvanometer or ammeter just like a simple resistance, and you know how to solve resistance problems in series or parallel. You know that, right? So that's it. Just solve it like that. Okay, you'll get a hang of it. Just follow my lead. In the given circuit, the voltmeter records 5 volts. The resistance of the voltmeter in ohms is Acha. Now, what does this actually mean? See guys, this voltmeter also has some resistance. Let's say I call this RV. And it measures a voltage of how much? It measures a voltage of how much? 5 volts. Now, don't you see the voltmeter and this resistance are actually in parallel? So a better way of drawing this circuit, would have been, combining both these resistances into one single resistance, and I call it, let's say, R equivalent, because they're in, or R parallel, because these two are in parallel, along with this 50 ohm resistance, and then connected to this 10 volt battery out here. Now it is clearly mentioned the voltage which this voltmeter measures is 5 volts. That means the voltage across this is 5 volts. Isn't that clear? The voltage across these 2 points is 5 volts. So guys, quickly analyze and tell me what is the voltage between these 2 points. Quickly analyze and tell me, if this is 5 volts, How much is this much? How much is this much? Yes, Ankit, don't worry. Thank you, Abhijit. Oh, you missed my Gauss law videos. Well, Bhargav, actually Gauss law is not related to current electricity so much, so you don't have to worry about it. But please watch it at the earliest, because then you will start having a lot of backlogs out there. So it's better not to keep those backlogs. Okay, so try to finish it. Exactly, Yalini, Aishwarya, Chinmay, Abhijit, Mitali. Exactly. This will be also 5 volts. Now, if this is 5 volts, this is 5 volts. If this is 50 ohm, how much is this R parallel then? Come on, quickly answer this. If this is 5 volts, this is 5 volts in series. This is 50 ohms. How much will this be? Come on, answer this question. Got it, Bhargav? Very good. Chalo, think. Oh, Abhishek, 2% is not the answer, bacha. I mean, the question is something else. Yes, exactly, Ames aspirant. Exactly, Aishwarya. Exactly, Ankit. Correct. You guys got it. It is also 50 ohms. See, I was trying to solve the problem step by step. Now, this is 50 ohms, but this is actually made of 100 and this. What resistance in parallel with 100 will give an equivalent resistance of 50 ohms? Can you solve this problem? Isn't it simple? I mean, you can do it orally also, but for those of you who want to solve it by proper method, but it's okay, I'll do it for you guys. So, R parallel is 1 by 50, okay, and this is 1 by 100 plus 1 by RV. Come on, do the math. 1 by RV is equal to 1 by 50 minus 1 by 100. Take the LCM. This will become 2. This will become 100. 2 minus 1 is 1. 1 by 100. So that means RV is going to be 100 ohms. That's it. Beautiful. Beautiful. Correcto. That's it. The answer is B. Guys, what did you learn from this problem? Treat voltmeter, galvanometer, ammeter like a resistance. Solve everything like you solve the resistance problem. There is nothing apart from that. Those people who by heart, some institutes are doing this. They give a formula. They give some things to by heart for ammeter and voltmeter. I never have asked any of my students to by heart a formula for voltmeter and ammeter, because that will be evil. That will not be correct. That means you're not understanding what is an ammeter, you're not understanding what's a voltmeter. You just have to solve it like a resistance in series or parallel problem. That's it, that's the answer, 100 ohms. Let's get going to the next question coming up on your screen. Yep, Yalini. Thank you, Deepak, so much. Now we'll look at this question. There is a galvanometer, it has a resistance of 100 ohms, and the full scale deflection current is 50 microamperes. Construct a voltmeter of range 50 volts and find the approximate resistance of the voltmeter. Come on, let's do this. Let's do this. What's the approximate resistance of the voltmeter? Okay, so first of all, let's draw this particular thing, how it looks like. A galvanometer has a resistance of 100 ohms. Full scale deflection is also known, and it has to be made into a voltmeter of 50 volts. Okay, so galvanometer is nothing but like a resistance. So I'll just show a resistance out here. So resistance of the galvanometer, where is it? It's 100 ohms, okay. And I have to connect a resistor in series. Remember that? Resistor in series, because this is a voltmeter. Yep, I don't know what's the resistance. In fact, that's what we have to find. Okay, I do not know that. And this is always going to be connected in parallel. Remember, that's how the circuit works. And you will have your device out here, okay, across which you're going to measure the voltage. Now, what's the range of the voltmeter? That's 50 volts. Okay, so this is 50 volts. And what's the current flowing through the galvanometer? The maximum current which can flow is 50 microamperes. Now think about it. This is the maximum reading of the voltmeter. When maximum reading would be measured, okay, because the range of the voltmeter is 50 volts, then maximum current will be flowing through the galvanometer, which is 50 microamperes. Everybody clear till this point? Great. Now the thing is, what you need to do is start from here and go till here across this path, go across this path, you are going to get a voltage drop, and that voltage drop should be 50 volts. Correct? The voltage drop across this path or this path should be 50 volts. And we know what is the voltage drop across a resistance, IR. IR is the voltage drop. Now, hence, can you see the total voltage drop? The voltage drop, okay, will be how much? It will be current through the galvanometer into resistance of the galvanometer plus current, the same current will go here. So current through the galvanometer into resistance in series. Remember, the same current has to flow. They are in series. Yep. So what is the voltage drop? That's 50. Can I take Ig common? Yes, I can take Ig common. What is Rg and Rs? Rg is 100. What is Rs? Rs I don't know. And what is Ig? That's 50 microamperes. Now you can see 50 and 50 cancels out. And then take this 10 to the power 6 over here. So you will get 100 plus Rs is 10 to the power 6. That means Rs is 10 lakh minus that, you 100. Yeah, 10 lakh minus 100. It's 9,99,900, which is as good as 10 lakh. So I will approximately say this is 10 to the power 6, which is option A. Yes, which is option A. Correcto. Raj Shekhar, I will answer your question if you comment in that video, and definitely I'll post up whatever vaccine I took. Okay, so post it over there. I'll definitely answer over there. Yeah, that's the answer, guys. Option A. Beautiful, beautiful. Let's have a look at the last question for today, coming up on your screen now. Okay, Ankit, you can watch the replay a little bit. Okay. Oh yeah, no. Oh my God, Bhargav. 10 to the power 6 minus 100 is not 10 to the power 4. 10 to the power 6 divided by 100 is 10 to the power 4. Happens, Bhargav. That's a silly mistake. Okay. Consider the diagram shown. A voltmeter of 150 ohms is connected across AB. Then the potential drop across AB will be how much? Okay, let's do this. Remember, what have I been telling you? Voltmeter is nothing but a resistance, nothing else. So, connect a voltmeter. That means connect a resistance across points A and B. What is the resistance? It's 150. Great. Now, what do you do next? The question is, what is the voltage across A and B? Simplify the circuit. These are two resistances in parallel. So what will be the equivalent resistance? Come on, I'm waiting for all your answers in the chat box. Convert both of them into one single resistance. Meanwhile, I'm just completing the circuit. Come on, come on. I want the answers before I turn back. What do you think is the equivalent resistance in parallel is going to be? Okay, let's see how many of you. Oh, nobody yet. Come on, come on. Oh, you understood it too easily? Okay, thanks. I'm glad. Yeah, come on guys, do this. How much is it? Beautiful. 100 into 150 upon 100 plus 150. 100 into 150 divided by 250. Simplified, cut, put. Aishwarya has given the answer really quick. Very good. Okay, AIMS aspirant is already telling some answer of 15 volts. I don't know. Yes, 60 ohms. Beautiful. So this is going to be 60 ohms. Excellent. Now, all you need to do is measure the voltage across these 2 points. That's the question. So that means you have to just measure the voltage across this point. That's it, these 2 points. And I have told you a potential divider arrangement. Potential divider formula. When did I teach you this? In one of the previous classes when I told you about resistors in series and parallel. Check out session number 2. Okay, it's there in that. And that says this voltage difference, the voltage difference delta V across the 60 ohms is that resistance upon the total resistance into the total voltage, which is 50. Just do the math. I hope you remember this. If there are many resistors in series and you want to measure the voltage across any one resistor, so that resistor upon total resistance multiplied by the total voltage. That's the potential divider formula. Remember that. Okay, so this is simple. 60 into 50 divided by 160. 0 gone. This divided by 4 and this will become 15. So this is going to be 75 divided by 4, which is going to be 18.75 volts. Yep, option A. Beautiful. Excellent. So somebody had said 15 volts. I don't know why. Yep. Yeah. Yes. Beautiful, beautiful, beautiful. So that's the answer, guys. So guys, did you not understand voltmeter and ammeter in a very simple way today? And if you have enjoyed and if you have learned today really well, please hit the like button. It means a lot for me if you smash that like button, okay? Please do that. And this is your homework question. This is your first homework question based on ammeter. So the first question on ammeter and the next question on voltmeter. So post the answers in the comment section below. Once you solve it, the solutions will be provided to you in the Telegram channel. So there is a link by which you can join our Telegram channel. So do that. And remember, our classes are having a 2-teacher model. It's not just one teacher on YouTube. Okay, it's very limited. I can probably control so much. But apart from me, so this is me, the master teacher, you additionally have a class teacher who solves all your doubts in groups. There are small groups in which you are divided and all your doubts get solved. And even after the class, all your doubts get solved via subject matter experts. And after every class, you are going to get assignments and you are going to get the booklets. Now, what are these booklets called? These booklets are called Tattva material. So you get Tattva material, both soft copy and hard copy, both you are going to get. And you are going to get the notes in the form of PDF. Whatever the teacher writes, you're going to get it in the form of notes. And you will also get recordings till the last date of your subscription. It's not just for 2 days. And all our classes, like I said, are interactive, like quizzes, chats, doubts, concepts, 3D animations, all of this. And if you want personal mentoring, we have that facility with PTM, strategy sessions, guidance sessions for all of you. Now, this is where people get confused. Sir, which subscription should I take? See guys, whatever I told, almost all of it is there in the light version. Okay, like the classes, the test series, assignments, booklets, doubt solving during the class is there. But if you want doubt solving after the class, then you go for the classic version. Now this is where most of the people enroll themselves, in the classic version, because obviously you want somebody to solve all your doubts. You can take a screenshot, text, chat, get your concepts cleared after the class also. This is where most of the students get themselves enrolled. Now there are very few students, but they need some guidance. And you know, this is something which nobody gives. There are students who need that guidance. And when you need that guidance, you need that personal mentor, and that's when you go for the plus version. Now, these prices you can see, they are almost 1/5 or 1/6 of your coaching fees. I'm pretty sure you know your coaching fees, 2-3 lakh rupees. So these fees are almost like 1/4, 1/5, 1/6, depending on which coaching you're comparing with. And there is an option of EMI. So when you take it as EMI, when you take it as EMI option, so whatever price is there, you know, that will be divided by 12. So per month price will be very less, hardly this much. Okay, so that's going to make it very affordable. And remember, you already have this coupon code with you, SHHPRO, via which you can get this discount as well. Okay, so thank you guys very much out here for joining in. Thank you very much for listening. Thank you for being here and studying so well, and thank you for making this channel grow a lot. So I hope you guys are going to post all the answers in the comment section. And bye bye, take care. Bye bye Sakshi, Savi, ABCD, Tech Buddies, Manisha, thank you so much. Bye bye Ankit, bye bye Uday, bye bye Bhukya, bye bye everyone out there. Take care guys, take care. Good night, see you again tomorrow.